Okay, let's see what's going on here. From the Desmos Online Graphing Calculator, I've graphed f of x equals the square root of x minus 5, which is this red curve right here. I've plotted the point 8, f of 8, which is 8, comma, negative 2.172. And then I've created a table of h values, starting at 1 and then getting closer and closer to 0, which is what we want to do. We want to find the limit as h goes to 0. And I've added columns for f of 8 plus h, which f of 8 plus h is like, for a big value of h, that might look like this. So we're going from 8 this way. So if this is h, then this point right here is the point 8 plus h, f of 8 point h. 8 plus h, I should say. And if you were asked to plot the slope of the line between those 2 points, you'd use the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's actually what this formula is right here. The limit, this is a difference quotient. And as we let h go to 0, this distance is getting smaller and smaller. These points are getting closer and closer together. And when h actually hits 0, the limit will be the slope of this tangent line. That's what this is all about, finding a formula for the slope of a tangent line to a given point on the curve. And it looks like these values are getting closer and closer to 0.176, blah, blah, blah. And down here, maybe you haven't learned how to take derivatives yet, but I use the Desmos tool to calculate the derivative of f of x, which is just another function. And g of 8 gives me this as the slope of the tangent line at the point 8, which you can see that's 1 over 2 radical 8 or radical 2 over 8. Question is, how do I calculate that limit algebraically? And that's what's over here. So here's the limit as h approaches 0 of f of 8 plus h. I put 8 plus h in for x and the square root symbol, and minus f of 8, which is radical 8 minus 5. Before I start doing anything, I'm going to simplify the numerator by removing this parentheses right here, which means the minus 5 and the plus 5 will cancel out, and that's what I'm left with in the numerator. And now you're going to find this is a typical thing to do when you're trying to evaluate a limit containing radicals, is to multiply either the numerator and the denominator by the conjugate of the expression that has the radicals in it. And the conjugate means we're using the opposite sign here, plus instead of minus. Why do we do that? Because it's like a minus b times a plus b. And that's going to result in a difference of squares, a squared minus b squared. And I have a feeling you're not going to be able to see this because Desmos covers that up, or Wyzant covers that up. But you heard what I said. So when I multiply these two expressions together, I'm going to get a difference of squares, which just means I'll square the first term, giving me 8 plus h, minus square the second term, giving me a minus 8. The 8's cancel out. Here's the multiplier in the denominator. After I combine the 8 and the minus 8, these h's cancel out. And now I can take the limit as h approaches 0 by just substituting 0 in for this h right here. So I get radical 8 plus radical 8 is 2 radical 8. And I can simplify that to 1 over 4 radical 2 by simplifying this radical to 2 radical 2, and then I can rationalize the denominator by multiplying top and bottom by radical 2. So there you go. Hope that clears that up for you.